Next, we take a look at the probability using the analytic view. Imagine that you have a bag of M&Ms in front of you and you reach in and pull one out. To the right of the slide, you see there's a distribution of the colors in an average bag of M&Ms. Keeping that in mind, that there are 100 M&Ms in the bag, what is the probability that you will pull out a yellow one? Because 14 of the M&Ms are yellow, on average, your probability is 14%. Another way to state the analytic view is to say that if an event can occur in A number of ways and can fail to occur in B number of ways, and if all possible ways are equally likely, then the probability of its occurrence is A divided by the sum of A and B. And the probability of its failing to occur is B divided by the sum of A and B. 14 divided by the sum of 14 and 86 equals 0.14. We might also consider the frequentist view of probability. We might draw M&Ms from the bag, making note of each color as we do so, and then replacing the M&M back into the bag. This is called sample with a replacement, meaning that each M&M is replaced before the next one is drawn. If we were to do this many times, we would find that about 14% of our draws resulted in a yellow M&M. In this way, we could define probability as the limit of the relative frequency of occurrence of the desired event as we approach the desired event that we approach as the number of draws increases. So, probability is defined in terms of past performance. As the book says, if we draw green M&Ms 160 times out of the last 1,000 draws, the probability of drawing a green M&M is estimated as 160 out of 1,000, or 0.16. Some theorists have discussed the idea of subjective probability, wherein probability represents an individual's subjective belief in the likelihood of the occurrence of an event. I'll give you examples. Make note that when we sample with replacement, probability does not change. If we were to redraw and none were green, or redraw 999 times and none were green, our odds do not get higher for getting a green. They remain the same. We often get probability confused. We say the probability of losing at Russian roulette is 1 out of 6. We're referring to the fact that one of the gun's 6 cylinders has a bullet in it. And we only buy a particular car based on a Consumer Reports study that says it has a good repair record. We're responding to the fact that a high proportion of these cars have been trouble-free. We also do this with sports teams based on our subjective belief about probability. We might say the Razorbacks are due for a win because they lost so many times lately. Now let's look at some definitions. The basic bit of data for probability theorists is called an event, which can refer to just about anything. For example, when we are dealing with a process as simple as flipping a coin, the event is the outcome of that flip, either heads or tails. Two events are considered to be independent events when the occurrence or non-occurrence of one of them has no effect on the occurrence or non-occurrence of the other. In a secret ballot, whoever you vote for is independent of or will not affect my vote. Two events are said to be mutually exclusive if the occurrence of one of them precludes the occurrence of the other or nullifies it or makes it impossible. If you are a freshman in college, you cannot be a sophomore, junior, or senior. Each group is mutually exclusive. Is this true for ethnicity? No, not usually. An exhaustive set of events is said to include all possible outcomes. If a sample of 10 students included freshmen, sophomores, juniors, and seniors, the sample would be exhaustive. However, if there were no juniors in my sample, the sample would not be exhaustive. Probabilities range between 0 and 1. If an event has a probability of 1.0, then it must and will occur. If some of it has a probability of 0.0, it is certain that it will not occur. It is impossible. The closer the probability value comes to either extreme, the more likely or unlikely is its occurrence. The additive log probability says that given a set of mutually exclusive events, the probability of the occurrence of one event or another is equal to the sum of their separate probabilities. Therefore, the probability of getting a blue or green M&M is equal to the probability of getting a blue plus the probability of getting a green. According to our data, those two probabilities are 0.24 and 0.16. They add up to 0.40. Thus we have a 40% chance of getting a blue or a green. The multiplicative law of probability says that the probability of a joint occurrence of two or more independent events is the product of their individual probabilities. The book gives us an example. If I were to draw two M&Ms, replacing the first one before drawing the second, what would be the probability that I would draw a blue M&M on the first trial and a blue on the second? This is much more unlikely. The probability of picking a blue, which is 0.24, is multiplied by the second event probability. Again, 0.24, giving us a 5.8% chance. A blue followed by a green results in a 3.8% chance. What is the probability of the green followed by a yellow? A joint probability is defined as the probability of the co-occurrence of two or more events. Here I give the example of looking at a random sample of people to determine the probability that someone will be promiscuous and have a sexually transmitted infection. Both events or criteria must occur. If two events are not independent, we use a conditional probability. For example, we could determine the probability that someone will get a sexually transmitted infection if they are promiscuous. If we want to understand the probability in a conditional sense, we are talking about a conditional probability. On this slide, we see the relationship between death sentence and the race of the defendant. On the left-hand side, we see a column that identifies black or non-black. In the row across the top, we see that there is an option for receiving the death sentence or not receiving the death sentence, and the total. So without taking into account the ethnicity of the defendant, what is the simple probability that someone will be given the death penalty? It is 17%, or 0.171. Now, let's look at just black defendants. Based on this data, the probability that a defendant is black is 0.780, or 78%. The joint probability that a person is black and is sentenced to death is 0.142, or 14%. This gets really interesting when compared to other races, generally speaking. If someone is non-black, they are 50% less likely to get the death sentence. Their probability is about 13%. Next, we'll talk about odds and risk.